Okay, part 3 of algebra. We're going to talk a little bit more about rearranging, but also how we can do some more complicated combining of equations and manipulations. So let's take the example of an equation which comes from physics, which defines the gravitational constant, the acceleration due to gravity. This doesn't matter too much for you to know all the details of this, but just trying to give it some context. So G equals capital G times m divided by r squared, where r is a radius, G is another constant, and m is the mass of something, and G is the gravitational constant, the acceleration. So how could we rearrange this to make m the subject? Okay, well let's how are we going to get m by itself? Well, we need to get rid of this big G term and this r squared term. So let's deal with the r squared term first. If we multiply both sides by r squared, then this r squared will cancel out. So let's write that out, and we'll do it in full. Gm r squared over r squared. Remember, we're doing the same to both sides. So these r squareds cancel out. R squared divided by r squared is just 1. Okay, now we're left with little g r squared equals gm. Now we just need to get rid of this g, and we do that by dividing both sides by g. So now I have g r squared over big G equals big G m over g. These cancel out, and so we're left with m equals g r squared over g. Okay, fair enough. Let's think about how we might use this. So this is mass. Let's think about how we might apply this to a planet. And let's think about how we might be able to think about the density of a planet. So to do that, we're going to think about the volume of a sphere. So volume of a sphere, which you may remember, is V equals 4/3 pi r cubed. Pi the constant, V for volume, and r is the radius. And you can write this as 4/3 pi r cubed. We can also write that absolutely equivalently as 4 pi r cubed all divided by 3. Okay, those both mean exactly the same things. Now, density is normally given the Greek symbol rho, which is a bit like a curly P. Density is mass divided by volume. Okay, we've got our expression for mass here, and we've got our expression for volume here. Let's combine the two together and see what we come out with. See if we can come out with an equation which is due for density. I'll switch sheets for that. Okay, let's just write it here. So density equals mass divided by volume. So if we take what we had before, so our expression for m was g r squared over big G. We'll write it like this to start off with, divided by volume. So volume here is 4 pi r cubed over 3. Now you may remember the easiest way to replace this divide sign is to turn this up the other way, and then we can make that a multiply. So this then becomes g r squared over g times 3 over 4 pi r cubed. Okay, now we can just multiply straight across. 3g r squared over 4 pi big G r cubed. Okay, typically we write the numbers first before we get to the letters. Okay, so now final bit of simplification. We've got r squared up here and r cubed down here. Remember, if we're dividing, we subtract the powers. So this would be, what we would be left with is r to the power 2 minus 3, which is r to the power minus 1. So we could write that like this: 3g r to the minus 1 over 4 pi g. So that's how we've dealt with those bits. But remember, r to the power minus 1 is the same as 1 over r, and really we would typically write this as 3g 4 pi gr. Okay, that's an example of combining some algebraic expressions together, and you will get some more practice at this.